Okay, good. I don't need to be host.
Welcome aboard. We have a lady.
Okay, we're on live airtime.
I think we're on YouTube, everybody. All right, welcome to the SBAU Astro Hour. My name is Ronnie Heron, and longtime member, passed away. Well, we miss him. His name is Bruce Murdoch. So we're 5 short, but now back up to 6 with a special guest. Listen, the show is about to kick off its 6th year of the Astro Hour. That'll be in 2 months, March 1st of 2026. Welcome aboard. Even though my voice is in not a good shape, here's what we're going to talk about this week. We got a big holiday smile out there, tracking the happy face asterism in Auriga the Charioteer. If you're looking for pops of color, we'll open up cluster M41 for you. Space is apparently not empty, gang. Where exactly are the first Big Bang atoms? If not, they're in the stars and galaxies. And we're going to show you some exciting new exoplanets, all discovered in 2025. For example, there's one called K2-18b, which could have life. There's a new analysis of 7 Earth-like planets orbiting the TRAPPIST star. I assume that's TRAPPIST-1, or does that refer to the first planet? Well, we'll find out. Light years away, 40 of them. TO1-561 is one of the first metal poor planet systems discovered in the Milky Way. And in case you missed the New York Times this morning, they had this story, something we covered a couple weeks ago. Your zodiac sign is 2,000 years out of date, everybody. Because today's constellations don't exactly match up with the ones from 2,000 years ago. Okay, as we mourn the loss of Bruce, let me introduce the brain trust of the Astro Hour to you, ladies and gentlemen. Recently reelected for his, I think, 9th year, Jerry Wilson. Jerry, Captain.
Good morning, everybody. And my sister Joyce and my grandkids, Riley and Calvin.
And that lady that Jimmy Durante used to say hi, is she still alive? Or she said goodnight, Balderdash?
Oh, you're talking about the Good Night, Mrs. Calabash, wherever you are. That was Jimmy Durante in the 30s and 40s.
All right, Jimmy Durante?
Yeah.
He the one with the nose?
That's the one.
What did I say? I thought I said Jimmy Durante. Well, anyway. Pat Forgy is your very supportive, loving wife. And I hope your holiday season, which is only half hour, has been great. Chuck McPartland is our outreach guy. Hello, Chuck.
Morning.
He's one of the best. He's married to Pat, who's not only our merchandise manager, getting rid of that merchandise in one big long garage sale, as well as our recently reelected treasurer. Take them by order here. Tim Crawford joined us. Tim,
Hello.
You decided to go out on the plane below Gaviota. I see you. Join us. Thank you for that. Kind of outdoors.
I don't know where that is. It's actually flipped, and somehow putting this on the screen,
Okay.
I got a east-west flip on it, so I don't know where that is.
I don't see 101 on it, so I don't think it's our coastline, but
Chuck's probably right. It's maybe Hollister.
okay. Well, Karen is your wife. And here's Tom Whittemore, editor of our newsletter.
Morning.
And he's married to Maureen and secretly misses running those Bunsen burners in his lab out at Westmont. And joining us is our outgoing secretary, the beloved Tessa Flanagan. How are you, Tess? You're going to have to unmute your...
Doing fine. Thank you very much. And I appreciate your inviting me to the Astro Hour, Ronnie.
Well, I appreciate you joining us. Can I call your significant other a guy named Duff? Since I give everybody's mates, he's always with you. I assume you didn't get my email. What?
He's over here smirking to the chair a few feet to the left of me.
Okay.
Well, there's a big invite on your inbox from me. You're going to have to open up. Another one I sent you, a long one. But anyway, we have a lot of fun here, and I have moved my position blurred the damn stuff behind me, my dining room. We always open up silly cartoons. We're going to do that right now.
Before we get to the cartoons, let me just point out that one of our regulars on this program passed away on December 18. Bruce Murdoch. He's an integral part of our team. And he's a retired electrical engineer from Delco. He is an active astro imager and outreach supporter. He frequently carried a 3-ring binder around of his images to show at the outreaches. It was a big hit. And he was a key member of this radio, or this blog that you see. He will not be with us, obviously, at future broadcasts. And just saying that he was much loved and we will miss him very much.
He was also president of the Santa Barbara Theater Organ Society. They're now going to need a new guy in charge. But I think he liked astronomy as much as he liked pipe organs in the Arlington. And he was always good to me. Did you want to say a few words, Tessa? You're going to have to unmute again, dear.
Yeah, you don't have to, but.
Yeah, we don't have to. Ronnie specifically invited me. My impression was that this was going to be, the whole hour was going to be discussing Bruce as kind of a memorial. I'm sure I didn't know him nearly as well as most of you, but I did have a chance to talk to Charles Schuler, and I'm very impressed that he and Bruce managed to turn the disaster of COVID into a real benefit by going out and doing little 2-party star parties. And they became so knowledgeable about our local hills here that they could go up to our favorite place on El Camino, Camino Cielo. And if it was too windy, they would just go a little bit further to an intersection, go up 200 yards, and there was a pullout, and then they'd set up there. And if that didn't work, they'd go over to Painted Cave and go down a little bit, and there was another open area. And they just became so knowledgeable about being able to find someplace that would work. I'm really impressed about that.
Yeah, they were unstoppable.
Yeah. We'll probably have more stuff to say this Friday night at our January 2nd, first Friday meeting of January, when Dr. Crystal Martin takes us back to the dawn of time, a cosmic dawn, she calls her speech. Are we going to do the cartoons?
Okay, we can do that.
Get into a lively mood here. And thank you for that, Tessa. And
yes,
you're invited to stay with us and comment. Makes the screen balance with six pictures.
Well,
actually,
thank you.
I added 2 more.
Added 2 more cartoons?
Yeah.
Okay, well, the 6 you sent us were, this is a new one. You better run us. Is this the arc unloading? No.
This is animals 2x2 breaking down the barrier at the NASA gate and heading toward Starship out here.
Two of every animal.
Something big's going down, sir. They're heading your way now.
Swat those mosquitoes when you get a chance. Okay. Oh, I like this one. Carbon dating.
Or
Anybody
something.
want to take this one? Like it, Chuck?
So you got a lump of coal sitting there saying, you look older than your profile picture. And on the other side of the table is a diamond going, I've been under a lot of pressure.
Pretty hard to see that those are the same things, aren't they? Okay, Tim Crawford, what is this?
Well, it looks like a U-turn sign, but it says into lead eventually?
Yes.
Uranium.
Uranium turns into lead.
Uranium, Tim.
You can tell how old something is by how much of the uranium has turned into lead.
I thought maybe it was plutonium. What's the sign for plutonium?
PL.
PL.
PL, of course. Okay, Tom Whittemore.
There's
Jerry,
I don't see any words.
All right, Jerry, you want to explain this?
No, it's all in the setup here. This is a complaint department at a department store. And there's a woman here with a chemo kit and a bad look on her face, and she's holding a little kid that apparently has turned himself invisible.
I
Okay.
haven't seen any of these, so it's good. I'm seeing for the first time. It's really cool.
Well, he did send out a package of 6, including this one. Anybody want to try it? Tom, do you remember seeing this?
Um, we're here, the most beautiful planet in the galaxy. How can a planet sparkle like this? The guide says when sunlight hits the atmosphere, it sparkles as it passes through the particles in the air. The inhabitants here called it microplastic.
Oh,
Gifted artists they were.
Oh God.
Unfortunately, that's true.
yeah. Okay, Mr. President, what are we
Here's a
looking at?
picture of the moon as it is. Here's the photo I took of the moon. See, it's right there.
Okay. And we got 2 more aliens inside a flying saucer doing what you saw a lot of in Close Encounters of the Third Kind, Spielberg's nicest movie of aliens ever. And he says, I don't know about you, but for the record, I did not see that. Remember that jet plane pilot said that? You want to report an encounter? No, then nobody would believe me. It was one of my
Yeah, there's
favorite
back 50, 100 years ago, they would decide not to look like they were crazy people, so they wouldn't report encounters like this.
Okay. Who wants to take this one on? Chuck again?
Earth's astronomers have named their galaxy the Milky Way.
Okay.
And Zeus over here is saying, I thought Snickers was the one with the nuts in it.
Oh God.
Well done. Yeah, that's God's version. Okay, we got stuff to talk about. And Tessa, you're invited to join us if something occurs to you.
Okay. These are 2 things that I found in Astronomy magazine that are patterns that I can't see. And some people really do this. I forget the name of it again, but where human beings spot patterns in things that are just random.
Pareidolia.
Pareidolia.
Pareidolia, yeah.
Oh.
So this is one of them is in one of these 3 open clusters in Auriga. And I think of Auriga as the line going here and here
Yes.
and up there. So but these are the clusters. They're easy to see this time of year. There's Orion over here. And so let's see how I get to the next. Now this one is M38. And it's a close-up on that. And let's see, what's the
Just to the right of it is that smiley face.
that's right. It's they're trying to claim there's a smiley face here. Now I see this as 2 eyes, and this as a broad smile. Is that what you see?
Yeah.
I would call that a frog face, not a
Yeah, I
smile.
think frog face is better.
Yeah. Okay, good. So I'm not going crazy with this.
And it's a
No.
smile not with gravitational lensing. That's a different type of smile, isn't it?
Yes.
And here, this is M38 close-up. And the claim is that people see the Greek letter pi in here.
It's on its side.
It's on its side.
Hmm.
Which side?
It's tilted over toward the right. It's rotated clockwise.
So this is a leg, and this is a leg,
Yeah.
and this is the top. So the
Yeah.
pi is in darkness.
Well, no, I wasn't seeing it in darkness, but it has a very thick top to it.
Okay. Oh, so there's stars line up for the leg,
Yeah.
for the top, and okay.
Well,
Okay.
I have a little gin with
Actually,
my
now that I
eggnog.
look at it and you say it's on its side, it looks like the open mouth of that monster from the id in Forbidden Planet.
This is a star cluster,
Yes.
Yeah. This is
An open
M38.
open cluster.
It's a very pretty cluster. They're easy to find. They're good objects for amateur telescopes.
Hmm.
And binoculars.
Yeah, and binoculars. The next one is a pop of winter color. A lot of the brightest stars in the sky are in the winter sky. This is not some of them, but this is a very colorful cluster. It's M41, and you can see it right here in the Big Dog, hanging right below Sirius this time of year, about 11 o'clock at night.
And it's often called the Pleiades.
The Pleiades, that's right, I forgot that.
Right next to a very strange looking swastika. Did you notice that?
This is a color photograph or image of it taken by an amateur.
Oh, that's
And
nice.
this is by Chuck Ayub. He used a Celestron RSA 400 focal length. Anyway, it's in the caption. Oh, come on in. And it is there's a lot of bright blue-white stars, very hot young stars. And there's a lot of big old red giants in it too. And they contrast in this nice bright color pattern in the cluster. So it's a good thing to look at when the moon is up, like it is now. I think we're just a day past first quarter.
Mhm.
So moonlight is starting to interfere, but you're going to have trouble for about 2 weeks seeing faint fuzzies. But these clusters are very dramatic, good objects.
We do a lot of clusters on this show.
Now,
is this the dark matter?
What's that?
You had a story about dark matter stuff.
Yeah, this is a story about dark matter. Get rid of this pop-up. I've got a cat running back and forth on my keyboard.
Speaking of dark matter,
Look out.
they're all black, aren't they?
So what they're looking at is where is dark matter? And this is an illustration. It's an artist rendering of concentrated dark matter in the heart of a spiral galaxy like ours is. And this is the way the dark matter is intended to be, or believed to be, and then it's represented by the artist, that drives that galaxy. It's also where the supermassive black hole is, if there's a one in a galaxy, and there's one in almost every galaxy, apparently.
Huh.
Now this shows that was essentially dark matter. This is an image, an artist image of the cosmic web, the underpinning structure of our universe. So these are webs of galaxies and galaxy clusters, and the bulk of regular boson matter, baryonic matter that we know of, that we call, our cars are made out of and stuff, actually resides not in stars, but it resides in these voids between the galaxies. There's very, very little material there. There's like an atom every 35 cubic meters or something like that. And but it all adds up. These things are vast. And so most of the matter that we know of is in there. And
that was a Rubin product, a Vera Rubin observatory. So it's already, making all kinds of good measurements.
Oh, yeah, these are measurements from the Rubin telescope, yeah.
Your talking points, though.
Well, no, this says it's an image.
But the original atoms that were first created by the Big Bang are not in the stars and the galaxies?
Yes, they are, but most of them are in the voids.
Yes. When a star makes the elements in its core through fusion at different stages, depending on the size of the star, it can get farther along. But then it usually dumps that material, usually in a nova or supernova or a planetary nebula. Somehow it sheds that stuff, it throws it out into the vacuum. And it mostly stays there again. So in some cases it reconcentrates and starts forming star regions again. But most of the matter just stays out in space. That's where it is.
And in these voids, it's probably primordial material because you wouldn't have had stars forming in them as much as you do along the web.
Well, it wouldn't be the higher elements anyway. It'd all be hydrogen and helium, wouldn't it?
Mostly, yes.
Lithium.
Huh. They also call these the filaments.
That's the little web structure. Yeah.
Yeah, that's the way, and it looks suggestive like neural networks in a brain, which
But
leads to all kinds of crazy speculation on the internet.
Yeah.
does it get concentrated in what's called the great attractor?
No, the great attractor is more like a huge group of galaxies,
Yeah,
we
Well,
think.
that's what I meant. Does it concentrate?
yeah, it's
That's
kind
right.
of concentrated, but
Well,
it's a cluster of clusters.
yeah,
The
it's
thing
just
is that
like
we
that
don't know.
blob in the middle there, you
Yeah,
know.
we don't know exactly what the great attractor is, because it's in a part of the sky where the core of our galaxy blocks it. We can't see outside the galaxy in that direction. So
Oh,
it makes it
I
sound
see.
more mysterious.
Got it. But there's a theory then that all the galaxies in the universe might be orbiting a common center.
No,
No.
No?
that has
That-
been explored and it's not the case.
Okay, just it stops at the galaxy level, the orbiting thing.
There's a lot of turbulent motion in the universe.
I thought it'd be so neat
Clusters don't just form that way.
since moons orbit planets, and planets orbit suns,
Yeah.
and suns orbit black holes in the middle of galaxies. Wouldn't
Well,
it be neat that the whole universe is orbiting? But I guess it's not happening that way.
when planets orbit a sun, it's because the sun is the dominant gravitational force around, and it's a central force. And so there's an orderly motion of the planets around the sun. But everywhere in the universe, gravitational fields go on forever. And so right now, you, I, and everybody are at the vector sum of the gravitational attraction of every single body in the universe. So we are dominated by what the Earth does, and then secondarily to the sun does. But if you're way out in space, away from everything, you're not dominated by something being super close. This average background is going to tug or pull on you very weakly. So it's going to create what appears to be like chaotic motion. Do you see what I
Well,
mean?
well, Mr. President, what you just said has led me to wonder how in the world we can ever get a direct sighting of something that's 13 billion light years away. How in the world could those very distant galaxies make it all the way here in a straight line? And because light waves do get affected by
Light
gravity. I know
waves,
Chuck is shaking his head, but I really wonder why doesn't it veer?
light waves move in a straight line called a geodesic, but it's not straight according to us. It follows the contours of a volume that is tugging this way and that in gravitational fields. It's like a bunch of hills, and you have to run around the hills at the same altitude. So it's a very wavy path, but it gets to us. That I'm not quite sure what you're asking.
Because most of this is void, as you see in this picture, the light waves only get bent following the geodesics in space-time when they go past something really massive. And most of space is empty. So essentially those are straight lines. But you do see the gravitational lensing, which distorts the view behind you when that light happens to travel along a geodesic that goes close to something very massive. So overall, space is pretty empty, and that's why it's more or less straight lines out to as far as we can see.
Well, those
But
distant
even
views really look crowded to me.
even when it's not straight lines,
Deep field.
your eye assumes that it came in a straight line from
Yeah.
wherever its last few feet of travel was.
Well, my impression was when they defined black holes as even light can't escape and light can go get sucked in and circle, then light is just as susceptible to all that gravitation as matter is. Light is not matter.
Yeah,
It's
it
pure
is.
energy.
Yep, yes, it is.
And
Light E equals mc squared, Ron. Light has mass,
It does not
rest
have
mass or
it does
whatever.
not have rest mass. It has mass.
Yeah.
It
oh, it
has
does.
momentum and it has energy.
Okay, I learned
How
something
many
new.
times have we?
Did
Okay.
you know that, Tim?
You know, I'm looking at that image, and I'm kind of like really mesmerized by it. Are those also considered to maybe be bridges, light bridges?
Hmm.
These are clusters of galaxies.
So they're more like mass bridges, Tim.
Yeah.
Okay, so it's the galaxy bridges. They're even if you'd have to magnify it a lot more to see those.
Yes.
Okay.
So, and there are a number of chains that have been named where galaxies interact with each other, and you can see streams of stars between them.
Is there any theories about the emptiness of space being this dark energy?
Oh, there's a lot of theories about it.
Yeah.
Tessa might have something to say about that.
Okay.
Madam Flanagan?
Not really that would contribute anything to this particular discussion.
Well, you were going to talk to us at one point about dark energy. I thought maybe you'd heard something new.
Well, we're all waiting for her. She's going to tell us what dark energy is. Anyway, um,
You bet. Well, I thought when Ronnie asked his last major question, I thought he was proposing a new religion with the great central gravity in the sky.
Central gravity? You mean the great attractor?
I told a friend of mine who's very religious that when scientists don't know something, they put the word dark in front of it. When religious people don't know something, they put the word God in front of it. God did it. So anyway, this is the current view of where the matter is in the universe, and energy and matter are the same thing. So we're mostly dark energy, and this is believed to be what is causing the universe to expand, to continue expand. There was a while ago when we measured the expansion and said it's increasing, and new research shows that more recently it appears to be the increase seems to be tapering off. So I tell people the third derivative change sign.
Yeah.
So it's a little over a quarter dark matter and about 5% ordinary or baryonic matter. And this is the stuff that light interacts with. So this is matter that's charged. This is matter that doesn't have a charge.
Charge.
It doesn't interact with light, is what that means.
Yes,
I
it
got
doesn't
that. I just
interact
never
with
heard
light.
it referred that way.
Whoops.
Huh.
Now, the next thing I found very interesting, this is a artist rendition of artist renditions of exoplanets. And the only useful thing about it is the sheer number of them. We've come across about little over 6,000 exoplanets right now. And there was a summary in, I believe it was space.com of the advancements made in exoplanets in 2025. Some of it, they're not all new discoveries in 2025. Some of them are discoveries earlier that are taken back, or some of them are things that were believed to be true that now they're not believed to be true. So it took up the bulk of our talking points, but very interesting. The first one is that there are a lot of Tatooine worlds. This is a scene from Star Wars with Luke Skywalker going out to check his moisture pump. And you can see the two suns of Tatooine off here settling, having a sunset. Interesting, there's no shadows, but this was 1970 CGI. Now, there are a lot of Tatooine type systems. One is Kepler-16, shown here. This is the Earth's orbit and Mercury's orbit are written on here for reference. But this is the orbit of Kepler-16b. These are the stars, Kepler-16a and b. Little b is the planet, big B is the secondary star. So this is a tight pair of a binary pair. The larger stars going around in this tight circle around a common center of gravity, which is located between the two stars at every time. This is the orbit of the smaller dwarf star. And this one is far enough out that there'll be wiggles in the orbit. It's not as clean as they show here. There'll be slight variations in it, but it will still have a stable orbit out here as these things change. If Kepler-16 were much, much closer, then it would no longer be a stable system. It would be a three-body problem, and it would eventually fling the planet off into space.
Really?
Comments?
Isn't our closest neighbor similar to this? Alpha Proxima Centauri?
Proxima Centauri is a red dwarf star.
Oh, okay. But aren't there two or three? Is it a threesome or a
Yeah,
binary?
Alpha Centauri is a three-star system.
Oh, there's three then.
Yeah. It would be similar to where the 16 small b, the planet, would be the red dwarf, but you'd have to vastly expand the scale.
But Proxima doesn't orbit all three stars. It just orbits the smaller one, right?
That's correct.
Hi, you're back.
Are there any other planets around Kepler?
Not that I could find.
Kepler is not, it's Kepler-16.
Yeah.
They numbered the stars that had exoplanets that the Kepler mission found. This is like the Atlas comets, there's multiple ones.
Okay. This is a pair of binary stars. This is 2M1510AB. These are a pair of brown dwarfs.
Brown
A and B seen here. This is the DESI Legacy Survey from the Perimeter Institute. And this is the one that has a planet orbiting around these two stars. So this is another Tatooine system. And this shows the orbit that the planet takes around these stars. So these two stars are rotating here in this orbit, and the planet is rotating around this common center of gravity here. But again, with wiggles in it, but it's far enough away from the pair that the distance between them is not a major perturbation, and so the orbit can be stable.
You just referred to them a minute ago as brown dwarfs. They're red dwarfs, aren't they?
They're brown dwarfs.
Yeah. The
You can see
dwarfness has really very little to do with the fact that there's planets around it. It's just simply the dynamics of three bodies.
I thought brown dwarfs were like super Jupiters. You can't see them, they don't glow.
Sure, they glow in infrared.
Yeah.
Really?
So does Jupiter. Jupiter gives off more energy than it receives from the sun. It's still radiating away from gravitational collapse. So
I'll be damned. Did you know that, Tessa?
I did.
Okay. Of course.
I took Sean Kelly's class at City College. What can I say?
I hope he's in the audience Friday night. Okay, what are we looking at?
This is an artist's rendition. Most of these exoplanet things are going to be artist renditions of a gas giant planet, K2-18b, that it made the news about a year or half a year ago, because in the atmosphere of the thing taken by using spectroscopy from the James Webb's telescopes, they found dimethyl sulfide and dimethyl disulfide, which are products of life. And so the speculation immediately became that this is a water world teeming with life. So now they have decided that that's not likely to be the case. There's other ways to get that. Independent analysis has challenged that interpretation. One group showed that non-biological gases, including propene, propine would reproduce the same spectral features without invoking life. And another one claimed and pointed out that, as we remarked when we saw the spectra from JWST on this show about a year ago, that it was very difficult to pick out the exact line. The data was way too noisy. And now that's the consensus.
Wow. Isn't another indicator oxygen in the atmosphere?
I
No.
don't recall oxygen being discussed. The key issue was the disulfide, sulfide and disulfide.
And that's because that's produced by algae here on the Earth in
Yes.
water.
Sounds like something that would be on Venus.
There's not water in the form of liquid water on Venus.
Yeah.
But they did talk about finding that dimethyl sulfide in the atmosphere of Venus.
Yeah. And someone speculated that there was life in the atmosphere of Venus.
Whoa.
So
But
there's no shortage of creativity among scientists.
are sulfides a stinking element? I think they are. Aren't
Quite
sulfides?
often, yeah.
All right, this is going to be TRAPPIST, right?
This is the TRAPPIST systems with the 7 little dwarves. Someone actually proposed naming the planets after the dwarves.
Sure, Dopey's there in the middle.
Mhm.
Right after this TRAPPIST system was discovered, we happened to be traveling through Brussels airport in Belgium. And it was discovered by a Belgian telescope system. And they called the system TRAPPIST. And it was a mnemonic for Transiting Planet
Yes.
Investigation System or whatever. But it was also named TRAPPIST because there are a lot of Trappist monk monasteries that brew beer there. And they had a big banner in Brussels airport saying, you know, we discovered this planetary system and we named it after beer.
Uh-huh.
Isn't Brussels in Belgium? They could call them
Yes.
Brussels sprouts. If they were green. But there's Earth in the middle of that, right? Or is that just a planet that looks like Earth?
These were just speculative assigning atmospheres to them, whether they're in the habitable zone or not.
Okay. But somehow they can see all 7.
Among these are labeled with lower letters A, B, C, or I guess this is B, C, D, E. So this one here is TRAPPIST E, and this is the one that spectrographs taken by JWST saw methane in the atmosphere. They've re-examined this with a lot of other instruments and again with the Webb again, and they've decided that the methane they saw was contamination from the sun, from its sun. And it turns out that now this is believed to be a barren world without an atmosphere.
Okay. That'd be like the moon Titan. Probably has lakes and seas made of
Well,
liquid methane.
no, the signal of the methane was in error, that it came from something else.
Oh,
Yeah.
I see. I got it. But are they all of the Goldilocks?
No,
Yes.
a couple of them are.
Yeah. D and E, A or B, C, D, E. These two are in the Goldilocks zone. But for this star is so dim. I think it's 1/400th of the brightness of the sun. The Goldilocks zone is like inside of Mercury's orbit here on Earth. They're quite close. And these kind of stars have big eruptions and flares. And so they also speculated that anything this close to that star would not be stable. It would be washed by radiation too often and its atmosphere would be blown away. And that appears to be the case now.
So TRAPPIST is like our sun?
No,
It's bigger or smaller?
it's a red dwarf.
Oh, it's a dwarf. And yet it gives off that kind of flares and prominences.
Well, they're more unstable as
Oh,
far
are
as their
they?
magnetic fields.
Well, my understanding was that red dwarfs last forever.
Yeah. But they
People
have
that-
convection in their atmospheres and stuff is bubbling up to the surface. And so you get all kinds of magnetic activity like we have when the sun is active with flares and things.
So what we're seeing here are the relative sizes, they think. They don't have a
Yes.
Jupiter around TRAPPIST.
Right.
This is
Okay.
all they could come up with. There wasn't a lot of material floating around when the sun formed there.
Wow. Oh, here's Proxima.
Yes, now this
Neighbor.
is
Hi, neighbor.
this is another artist rendition, and it's representing here Proxima the star as turbulent and full of flares and hostile to stability in these planets. This also shows that Proxima B and Proxima D are the only planets around that. I mean, they're eliminating Proxima C. It doesn't exist. So that's the data here from the NERPS planetary thing, Near Infrared Planet Searcher in the Canary Islands.
And you can see this picture, they tried to show that Proxima is a red dwarf that's very magnetically active, whereas they
Yes.
didn't in the TRAPPIST picture.
So this is a truer representation of what probably is going on there. This whole system would be a tough one to survive on.
What do you suppose the light would be like through a prism from a red dwarf? Would it still, because we see a yellow sun, don't we? And a red one would be what? Infrared?
No, it would be dim red to our eyes because we don't see infrared.
Okay.
But it would emit pink in the infrared, not in the green like our sun emits.
So what we're looking at here is the stars in the background on the right,
Yeah,
and the planet is in the foreground right in front of us here.
yeah, Proxima, but there's no Proxima C.
There's no C, huh?
No, this is not the TRAPPIST system. This is Alpha Centauri, our nearest one.
But there's other stars in this system, right?
There's not in this system. These are the planets around Proxima Centauri. There's also Alpha, Centauri
A and B.
A and B, thank you.
Well, that's what I meant.
They do
That's what
not
I
have
thought.
planets that we know of, but this is a triple star system. And Proxima is far enough away from the other two that it has its own planetary system.
And it orbits the other two big stars, bigger stars.
It interacts with them in a complicated way. But yes, they all orbit together.
Not the three-body system, is it?
It is a three-body system. And despite the movie's implication, a three-body physics problem is not insoluble. But it is not soluble in a closed form formula. You can't come up with one simple formula that describes the motion of everybody's body, everybody's motion in it. And we do it all the time with computers using finite element analysis. So we can model three-body systems very accurately.
But it seems like it would call for extreme calculus.
Not really, it's very simple. If you know a little bit of, Newton's laws and you know a little bit of finite element analysis, you can do it too. Bruce,
And speaking of Bruce did it, yeah.
yeah, okay. Now, next on our travel out there is
Next on the agenda, folks. God
this
only knows
is
where we're
a
going.
planetary system that is a ultra hot Jupiter called WASP, WASP 121b. It also has accumulated the name Tylos, Tylos. The James Webb Space Telescope has imaged the planet, and it has imaged two major tails in the orbit. So it's catching up to and flowing after helium tails that span nearly 6% of the planet's orbit. This is located 858 light years from Earth. So these are fairly big systems to see.
Helium tails?
What's that?
Helium tails?
Helium tails.
Huh.
So there's a planet inside that white
Yeah,
Q-tip swab.
it's so hot. Let's see, the surface, 2 million You don't see the temperature of it, but it's very close to, it orbits once every 30 hours
Oh, wow.
at a distance of 20 times closer than Mercury.
Oh God.
The intense solar heat vaporizes materials from the planet's surface.
No wonder it's a little hot.
Yeah, a lot,
You'd
just a
think all its
tad.
gas would go out into space, wouldn't you?
That's what it's doing,
Yeah,
Is that
but
right?
it's being held by the gravity of of its star.
Wow. Well,
Is
at
the
one
sur
point,
is the surface of that star helium, or is there's no connection with the helium in this star and
There's
the
going to be
big star?
hydrogen and helium in the star, but this is
yeah.
like a Jupiter planet, so it's got a lot of hydrogen and helium too.
Oh, okay. Hmm.
well, any astronaut getting caught in that tail is going to start sounding like Mickey Mouse. I heard that
Exactly.
helium is a unstable. I don't know what that means
No, it's
necessarily.
not unstable. It's a noble gas. It doesn't interact with stuff much.
Yeah,
So it does.
not
It's
chemically active.
not flammable and doesn't unite with oxygen, but it can make a tail.
This is TOI 561b. It's a small scorching lava planet that orbits one of the oldest stars in the Milky Way.
Discovered by Tess.
Yes,
That's
by
what the
Tess.
TOI means. So Tessa, there you go.
And it orbits its star less than a single day. It's very fast. The surface temperature of this planet is 3,140 degrees Fahrenheit, hot enough to melt rock.
Chances are it's tidally locked.
Yes. Well, I don't know that that means anything, but yes, I think if it's a lava planet, it's probably fluid, and the reason things get tidally locked is that they're not spherically symmetric. But if something is perfectly spherically symmetric, it has no thing to pull it into a certain alignment. It just gives it. So this might not be surfacely locked like that.
So our
This is,
moon is not
this is,
spherically
go ahead.
symmetrical. Wow. Amazing. How do they find these things out from this distance?
Science.
That's got to be
This
a ring
is
around something.
an observation taken with the Magellan telescope in Chile and the Large Binocular Telescope in Arizona. And this is WIS PIT 2b. It's a very young planetary system. It's only 5 million years old. Yet it's already formed a planet 5 times the mass as massive as Jupiter. The planet is here. The presence of newborn planets here is the first time one has been directly observed actively carving out its orbit. The team also identified a second candidate planet closer to the star. So that's here. And these are dust rings around when planetary systems are forming. And 5 million years is almost no time at all in a planetary system. These are all dust rings, and gaps in dust rings are where the planets usually pick up the dust and clean it out. This one is one where it's brightly shining from the star. One planet there and one planet there.
So that outer dust would be like our Kuiper or our Oort.
I don't
Yeah.
think it's that far out, but yeah, it could, yeah.
Wow.
So
This is an artist rendering, obviously.
No, this one's an image.
This is an actual picture taken by the Rubin.
So what is the glowing ring?
that's dust.
Like an asteroid belt.
And
Yeah.
it's just reflecting the luminosity of the star.
Yeah,
Yes,
or if there's some
that's right.
infrared imaging here, then it's from
It's
that.
picking that up. Yeah, okay. Thanks.
Yeah, if we get Mike Brown next fall, he might bring lots of pictures from that Rubin. That's what he's doing all this spring, is working on the big telescope. which I think has what, 1 trillion pixels? Or is it possible to have that many?
It's some huge number. But the main thing about Rubin is they can move it really fast and take images. And so they're basically taking a movie of the universe. Every 2 days they cover the entire sky.
Hmm.
And it's sitting on its own mountaintop down in the Atacama, northern Chile.
I don't, yeah, it's above the Atacama, but it shares it with the Gemini South, I think.
Okay, so they have all these different mountains that are up there, and it's dry and it's beautiful seeing, and they just,
And it's above most of the atmosphere.
and I guess Chile makes a pretty good part of their gross national product from astronomers.
Mm.
Well, we're not done, are we, Mr. Prez?
Yeah, I've run out of pictures. That's okay. We can still chat it up.
We should go back to that 2M1510AB where it has the weird orbit.
Also,
Because
that galaxy with the dark matter, which was portrayed by little blue sparkles at some point, that could call for some discussion.
so this
Oh,
is weird. This is really weird because usually when you have a solar system or group of stars like this that are bound forming, there's a shared rotation and you get this conservation of angular momentum, so stuff falls down into a disk. But in this case, you've got this right angle. So something happened that captured this planet, or,
Yeah.
it formed in a different way.
Yeah, I agree. This planet was not formed in this system. Or if it was, it had an extreme Uranus effect and got tipped on its side and knocked out of orbit.
Now the blue and the gold, those were put in there to show the
blue,
orbits.
these are drawings of the orbit
Okay.
this star is taking around this star.
It's
And
weird, the intersection of the orbits there, where your
Yeah.
hand is right there.
Well, that's the common center of mass, kind
Yeah,
of.
but these stars have to be moving in coordination. One doesn't move this way and then the other one goes this way. These both go in at the same time. So
Wow.
this one is here and this one is here. And then they swing around the common point with one there, and then they flail back out. And they're drawn here at their maximum out position. But it's timed so that this orbit here is primarily responding to this center of mass at this point.
How far apart do you suppose they
Clear
are?
as mud, eh?
Yeah.
Well, the thing is that there's no way that two of these planets would be swung over into one orbit because of that third larger orbit.
No, this orbit is not driving these orbits. These two orbits are driving, the sum of these two orbits are driving this orbit.
Huh.
Because this one's real tiny and these are very massive.
And there's no
Relative
way
to
that
that.
two of those would end up on the same side.
No, that would fly off into space. These two are coordinate. They're going, they're going around each other like this.
Huh.
And because their approach at the center of gravity is so close, is it assumed that they will eventually crash into each other or merge or something?
No, I don't see that. They look close because we're looking at an oblique angle. They might be quite wide apart.
Okay.
But science doesn't know.
Say what?
They've worked out the orbit.
Yeah.
But they don't know how far they are apart.
Sure.
Would it be when
Yeah.
they come in the closest?
Yeah.
Like
I mean, we've worked out the orbit. We know what their path is.
Here's those two stars right there.
And there's actually a third brown dwarf there.
Right there.
This is a really complex system.
Yeah.
It's amazing that they're synced like that.
Well, that happens. It's if you can get them to sync like that, they form stable orbits. We our system is not a system, our planetary system here is not a planetary system of independent planets. These planets all resonate with each other, so they're at certain positions. For example, we discussed a year ago, I think, Pluto's orbit and Neptune's orbit, they cross. But when they cross, the planets are not there. When Pluto crosses Neptune's orbit, Neptune is way far away. They're synced so that doesn't happen.
Yeah, if they had interacted, if they had actually come close, then one would have been thrown out and you wouldn't have that system anymore.
Right, exactly. It's
Yeah,
evolution.
I'm confused by this image. I'm now realizing that these are two stars, and the exoplanet is the one with the larger orbit.
Yeah, this is the exoplanet.
It's two brown dwarfs, Tim,
Yeah.
and then a planet that orbits them.
And if life were to be able to live on that planet, it would be really weird.
I think you can forget that.
Yeah,
These are
the change in temperature would be extreme.
well, this orbit, if you look at it, it might be quite circular. So they get a similar heating. I've read really interesting science fiction stories based on this when I was a teenager. One, without knowing this, one was a planet that was shaped like a football. And so you could actually go around, people would hike out to the pointed ends of it, and those would be out in the vacuum of space. And they'd have to hike back toward the narrower equator in order to have atmosphere. And that was another one.
The understanding is more than half the stars up there are at least binaries.
Yes.
Multiples. Is there a limit but beyond which they can't possibly stay together, like 4 or 5?
It gets harder and harder as you get more and more.
Yeah.
So it is possible, if this was a circular orbit, that planet would be equidistant from the two brown dwarfs?
Equidistant from the common center of the galaxy, or the common center of mass, roughly. These things, depending on how far out this orbit goes, it's going to feel the separation between them. Well, if it comes closer. No, it can have this kind of orbit.
Yeah, well, that's tattooing
The
right
junior
there.
level mechanics course where you figure out all these different kinds of weird orbits. It was fun working through the math of it. But one thing is then they had us do it if gravity was a inverse cube law. And there are no stable orbits in that world.
Might want to try to imagine what kind of sunrises and sunsets you'd have on that planet.
Well, I've mentioned this before, but there's that story called Nightfall.
Yeah.
About a planet that's in like a 6-star system.
Yeah.
And most of the time there's at least one star in the sky. But every, 50,000 years or whatever, all the stars happen to be on one side of the planet and you get darkness. And the people, the inhabitants go crazy because they don't know what it's like to have darkness.
Yeah.
There's another movie based on exactly that same thing, and it's called Pitch Dark. And
Yeah, there was a radio show on Sirius on that too.
Where what?
On Sirius Radio, there's one exactly like that. Matter of fact, I think it was named that, Chuck, and there was a group of scientists that knew what was happening.
Yeah.
And they all got together and they were just saying, well, something weird's going to happen now. We got to lock ourselves in here.
Yeah.
With a couple of candles or something.
It was a combination of astronomers and archaeologists, because the archaeologists had found this
oh, that's right.
This ruin that was like Troy, where it had multiple levels.
Yeah.
And they saw that they were spaced at this even interval. And at the same time, you've got astronomers that are starting to figure out the rule of gravitation, Newton's laws, and looking at these orbits and realizing that that same number of years, roughly, you get this nightfall.
The nightfall, yeah. Yeah, it was really something. They closed the doors and put some candles on so people wouldn't go crazy. They did some experiment where they put a guy in a closet.
Yeah.
It was a dark closet just to show people what would happen if it got dark. With about 2 minutes, the guy went absolutely berserk.
Yeah, in the book, there's a Disneyland type ride that they do where they would expose people to brief darkness. You know, somebody
Yeah,
thought, oh, this will be cool. It's like a
yeah,
haunted house effect. And
yeah.
people were actually just going nuts when they went through there. So there were lawsuits and, you know.
Well, imagine if they start finding life under ice on icy moons. They never get to see the stars and the sky either, but it's probably perpetual darkness down there, wouldn't you think? There's living creatures, no
Oh, it's
eyes.
like under Antarctica.
Well, I mean, like inside Enceladus or
Yeah.
Europa, which ones are they going to try to bore into and see if
Yeah.
there's.
Europa. Yeah.
Well, gents, we come to the end. You did good, all of you. And we miss Bruce. And I guess we'll all see you on Friday night when UCSB physics professor Dr. Crystal Martin will speak on cosmic dawn. And a week later, January 10th, our first New Year's star party. On that note, I guess we do like to say goodbye in a special way. Tessa, you want to join us in doing the
Asta Nebula.
Asta Nebula?
Thanks a
All right,
lot,
till
guys.
next week.